We are here to present our topic brain-machine interface. Let's start off with the introduction. What is brain-machine interface? It is a communication channel from human brain to computer. In simple words, a brain is collaborated with a device that enables signals from brain to direct some external activity. This application is based on a person's thoughts, and data flows from brain to outside machinery or to brain from outside machinery. The intention of brain is perceived as a command by the machine. The physical interface of the machine sends stimulus to the neural interface of the brain. This is the basic concept behind BMI. And there are three kinds of BMI devices: invasive, partially invasive, and non-invasive. The invasive devices are implanted in the gray matter of the brain during a neurosurgery, and the quality of signal is high in these devices. Eventually, the signal may become weak due to formation of scar tissue, and partially invasive devices are implanted outside the brain but within the skull. In these devices, the signal quality may be low, but the safety of patient is assured as the scar tissue is not formed. The non-invasive devices use neuroimaging technologies as interfaces, and the signal quality is low, but partial limb movements can be restored using these type of devices. These are some facts about human brain. It weighs around 1400 grams, and signals are taken from cerebral cortex of the brain. Basically, the brain is divided into two cerebral hemispheres, uh, that is the left side and the right side. It consists of four lobes which has different functions. These are the various areas, and the main principle behind the BMI is that the human brain consists of neurons which are connected to each other via axons and dendrites. The membrane of each neuron consists of ions carrying electric potential. The differences in electric potential create electric signals. With the help of these electric signals, neurons work. Scientists detect the electric signals and interpret their meaning to direct an external device. The intention of brain is sent as a command to the device connected to the brain. Uh, this will be continued by Anudeep.
Well, friends, myself Anudeep. Till now, my friend explained the activities of the brain. Now, I am going to discuss about the method of electroencephalography. This is the method in which the it is used in measuring the electric activity of the brain. And then this generates rhythmical potentials on the surface of the brain and forms surface waveform. And then if we think anything else, that the neuron collects the information which we think, and then this is and then forms the surface waveform. And then the next one is peak to peak amplitude of the waves can be 100 microwaves or less. This is the electric signals generated inside of the brain, that will be 100 microvolts or less. Coming to the frequencies, we have the frequencies of 0.5 to 50 hertz. This can be measured by this device. And then electroencephalography frequency range is classified into 5 bands, namely the first one is the delta, theta, alpha, beta and gamma. And then mostly used by this device is beta and alpha. Coming to this BMI, this has 4 devices. First one is the implant device, next one is the signal processing, the third one is the external device, and the fourth one is the feedback. Coming to the diagram, this shows the main 4 principles of 4 devices. The first one is the implantation device. The second one is the second till real time telemetry interface is nothing but the signal processing system. And the third one is the external device, and fourth one is the feedback. Coming to the components of this, we have 2 components. the first one is the hardware and the second one is the software. Coming to the hardware components, this records the brain waves, and then software has to analyze the data, and then it records the brain electrical activity of the device. And then coming to the software components, it reads the data and digits the data and pre-process the data and generates the output. That means whichever we think, and then that grabs to the device and then reads, digitize, pre-process the data and generates the appropriate output. And then coming to the four basic types, the first one is the implantation device. And then the diagram shows the small electrodes, and this one is kept at the top of the brain. It is attached to the skin, and then a small part should be removed so that it has to be attached. It has to be attached in the brain so that we can get the electrical signals from our brain so that we can generate the appropriate output. And then coming to the external device, this is nothing but, let us take an example of the artificial wheelchair or else a robotic arm, so that if a person doesn't have any hand, by using this hand he can touches the any items. And then this classifier output is the input for the device control. And then I have told you the brain, which we think that is an output, and then that is collected into the computer. This is nothing but an output. It is a device that subjected provides control motion, and then according to that it actually performs the appropriate output. And then coming to the feedback, this improves the performance of the brain, so that if any scientist or research he want to do any research work, so that the feedback is mainly, it is important to him, so that he can learn anything regarding the brain machines. And then these have two corrective mechanisms. The first one is the online, and the second one is the learning method. Now, in coming to the online, the correction of errors during the execution of movements, and then coming to the learning, which takes place after the execution of one or movements. And then this feedback can speed up the learning process. Next, my friend will discuss about the ethical concepts.
Hey, I'm Eric. I'm going to discuss some of the ethical concepts of this. And as I first began kind of researching this subject and things, I thought it was a far-fetched, far-away technology. But as I began researching it more and more, I ran into this right here and realized that we are actually using some of this brain-machine interface now. And then it got me thinking about what are the ethics of this and where is this to come in the future. Then right here is used for Parkinson's disease, and then it's been used by over 30,000 people in the world. And it's implanted in the brain, and it sends impulses that disable nerve cells within Parkinson's disease. And then, though this seems extremely incredible at the time, these technologies may seem rudimentary and commonplace in everyday living. And then scientists predict in the future that implants will be made from engineered tissue and organic nanomaterials rather than metal and so on. And this would make a seamless union of man and machine. And when I was doing the research on this, I was late at night playing around on YouTube, and it showed a man that had lost his arm within a car crash, and they finally developed a brain-machine interface with a robotic arm, and he was able to remember the movement of his arms and then finally be able to move it. And that really struck me that, this is here. However, once this technology transforms from helping with disabled people to different areas such as enhancement and so on, new ethical questions are definitely created. Brain-machine interfaces could be used for entertainment or work and many other areas. The U.S. military has already investigated future capabilities within soldiers of this, within soldiers being disabled and so on. And questions that are proposed by potential off-label applications of this brain-machine interface systems, just as steroids provoke a different discussion when injected to help hit home runs rather than being inhaled for asthma. Once this technology is simply used for enhancements, ethical questions arise and how this should be regulated. Also, if a group of people use this for enhancement, will there be a need to catch up? Other ethical questions with brain-machine interface is that they begin incorporating themselves within society. How will people view their sense of self as they incorporate other than human systems as a part of themselves? An example we used in class was, you have to have heart surgery, and a pig heart was transplanted into you. How would you feel about yourself then? And it's no different with a machine or a robotic arm. And as technology advances, there are more ethical questions that become relevant. However, some scientists feel that these ethical questions are not complicated to understand. This is because we have already asked these questions with the use of brain-altering drugs such as antidepressants. Like, human beings have been searching for chemicals to affect the brain, maybe from the first part when we found fermentation, and we're no different today. We've just gotten better at it. And then the use of this technology brings up the importance of this statement. Knowledge both brings considerable power and mandates increasing responsibility. To accept one without the other is a recipe for failure. Thank you. Sorry.
Now let's see the advantages of brain-machine interface. Every technology got its both edges, good and bad. Now coming to the positives of brain-machine interface, it provides a livelihood, and advancements in the technology make a person who is physically challenged to make him independent of steering his wheelchair. And coming to the next advantage, it provides linking up of a computer intelligence directly to a human brain, where internet access can be done immediately. The applications of BMI are auditory and visual prosthesis. Prosthesis mean the replacement of a part of a body. In auditory and visual prosthesis, we can have a synthesis vision and brainstem implantation. Coming to functional neuromuscular stimulation, where due to some damage or shock and a spinal cord damage, the brain and peripheral nervous system communication is damaged. With the help of FNS, it can be cured. Coming to the third one, it is prosthesis limb control, where the thought controlled monitor wheelchair and thought controlled arm of amplitude are used. Challenges of a BMI. Connecting of a nervous system could lead to permanent brain damage, and even virus attacks may causing the brain to ill effects. Future expansion of BMI are it helps a physically disabled person steering his wheelchair with the help of the mind. And the open question here is like, do people really have their head open, and where? As Anudeep said, we will be implanting a chip on the brain which will be open to the outside, helping for the interface of brain with the machine. To what extent people will use this technology? Here is a small video.
A brain-machine interface is a system that allows disabled people suffering from physical disabilities, to communicate with the external world and also to control devices. What we are doing is measuring the spontaneous activity of the brain, electrical activity of the brain, and trying to detect patterns that are associated to different intentions. For example, if I imagine just imagining moving my right hand, this will generate a specific pattern of activity in my brain. Now, if we develop the software that can do the real-time analysis of what is going on in my brain, I can detect that particular pattern and transform that pattern into some external action. The practical possibilities that brain-machine interfaces offer to disabled people can be grouped in two categories: communication and controlling physical devices and virtual devices. One example is this wheelchair.
Regardless the variety of cultures and diversities in the ethics, always the individual liberties and human lives are rated above all the machine intelligence, only because the human have the ability to think rather the machines. So here the essence of the question here is how the kind of a person we will be, not about what kind of computers are about to develop or how machines look like in the future, and what kind of the people are we becoming.
BCI technology opens a wide gate for merging technology with biology. It is a potentially high impact technology which brings rapid progress in many fields. Using BCI, we can have easy access to information and improve our ways of communication.
Coming to the conclusion, with the brain machine interface, this helps the people, a lot of people who has mental disabilities, or else the person unable to walk, unable to, if the person doesn't have any hands. So this technology is helpful for those people.
As this technology advances, have an opportunity to take many different paths, and it's our responsibility to make sure that it stays within ethical reasons and help mentally disabled people and advance the technology as it goes. Thank you.